Okay. So yesterday we did things with the 68, 95, 99.7 rule, correct? And we had just busted out the calculators yesterday, correct? Okay. So page 14, we are going to walk through what a whole problem like this should look like, start to finish, all the pieces that you need. We're going to be doing these by hand using table A today, so you're going to need that other orange packet that has table A in it that you got on the second day of school. Do you not have one?
No, I forgot the whole phone.
You forgot all the things.
Hey.
All right. I will need it back, and don't draw on it. But, all right. Not this color paper. Orange color paper like your packet, but looks like this. I need you guys to have this out. Okay, so the first thing that we're going to do, this is still using the same data set from yesterday, where we're talking about song length. What was the mean song length again? 220 seconds. What was the standard deviation? 26 seconds. And that was just on the front of the page. If you look at page 13, it's up in this box up here. It tells us the mean and the standard deviation. All right. It says that Ed Sheeran and Beyonce made the list with the song Perfect Duet, which is 260 seconds. What proportion of songs are longer than Perfect Duet? So the first thing we do when we're addressing a problem like this is we are going to sketch a normal curve. So go ahead and sketch a curve for me. Do your best. It does not have to be beautiful. Mine, when I hand draw them, are really ugly. What do you think goes right down the center? 220. Our mean goes right down the center. I have to let whoever is looking at this know that this is a normal curve. How do I do that? N, big N. And then parentheses, and what goes in my parentheses? Mean, 220. What else? 26 for our standard deviation. We need to label those. Mean, standard deviation. If you write the words out, that's fine. You can use SD for standard deviation. I use the symbols because they're fast and they don't take very long to write. But if you're not comfortable writing the symbols, you can write it out in words. All right, so 220 is smack dab in the middle. We want to know the proportion of songs that are longer than 260 seconds. Would 260 be to the left or the right of 220? To the right. So somewhere over here on the right-hand side, my location doesn't really matter except I've got it on the correct side of the mean. And I'm going to label that as 260. And then I want to shade this because it didn't say exactly 260, it said longer than. Which side of this should I shade? The right side. The bigger numbers, the longer songs are going to be over here. I need to change this into a z-score. How do we find z again? Value minus mean divided by the standard deviation. So let's do that here. Z equals, what's our value? 260 minus our mean, 220, divided by 26. What do we get? 1.54. That's not my answer. That doesn't give me a proportion. What is that telling me? .5 standard deviations above the mean. So I'm going to draw a second normal curve. This is my standardized normal curve. Once I standardize this, what goes right in the middle? What is the mean when we've standardized? I'm sorry, Abe, you said what? 0. It's still a normal curve. 0 is my mean when I standardize. What's the standard deviation? 1. And we're going to put this z-score on here. 1.54, about here-ish. And I'm going to shade it exactly the same way because I want to know the things that are more than 1.5 standard deviations above the mean. And now we're going to pull out table A. So we don't need the first piece of paper on the formula sheet. I'm over here. How do I look up 1.54 on table A? What's the first thing I go look for? 1.5 down this side. If you're on the front side of the page, you only have negative values here. I don't want negative 1.5. I want positive 1.5. So I got to go to the back side because that's where the positives are. Right, so now I go down that first column, that far left-hand column, I find 1.5 right here. And now what do? Across the top, we look for that second decimal place, that 0.04. Run your fingers together or use a straight edge or something to help you find your spot. What do we get? 0.9382. Now that, if you look at the picture at the top of the page, they have it shaded which way? They have it shaded to the left. Is that the same way that we have ours shaded? Okay, so I know that this area right here is 93.82% of all of the area underneath that curve. So how do I find the other side? Subtract it from 1 or change it into a percent and subtract it from 100%. So I'm going to do 1 minus 0.9382. And that means we get what? 0.0618, right? That is the proportion. So that would be, what, 6.18% if I wanted to write it as a percentage. The question up here said proportion, so I don't have to change it into a percent. I can just leave it in its decimal form. If you change it into a percent and it says proportion, that's not wrong, but you just don't have to change it. So far, so good? All right. Well, let's look at the next problem. Taylor Swift has many songs on this list with widely varying song lengths. We Are Never Getting Back Together is only 193 seconds, while Endgame is 245 seconds. Anytime they're giving me numbers in here, I'm underlining them to see, like, maybe it's not important, but I want to be able to come back and find it. Especially because if you guys have noticed, these stats questions get real wordy. So I'm going to circle my numbers so that I can go back and find them easily. What proportion of songs are between these two song lengths? I want you guys to sketch what a normal curve would look like for this. So like the first curve that we did on the last problem. Take about, I don't know, 30 seconds, 45 seconds. Sketch that first normal curve for me. hopefully, you have something that looks like this. I have 193 on the left side of the mean because it's smaller than 220. I have 245 on the right side of the mean because it's bigger than 220, and it said between these two song lengths, so I've shaded in between those two fences or those two boundary lines. Please, please, please make sure that you are doing this part also. Super important. Do not forget that piece. I want to draw a normal curve where everything has been standardized. What am I going to need to find if I want to draw a curve like this but where it's been standardized? Z-scores for what? For both of them. Go find both Z-scores for me. Find the Z-score for 193 and the Z-score for 245. After you find both of the Z-scores, I want you to draw a standardized normal curve. Okay, so after you find both of the Z-scores, I want you to draw this again, but where it's standardized, like this one. Does anybody have a Z-score for 193 for me? Negative 1.04 when we round it to two decimal places, right? What about for 245? 0.96. And then I wanted you to draw a standardized normal curve. Should look like this. We've got the negative 1.04 over on the left because it is below the mean. 0.96 on the right because it's above the mean. Make sure that you are doing this. And so I want to find the area that's between these two. Do you guys remember yesterday when we did the stuff with the 68, 95, 99.7? And if I wanted something that was between two standard deviations below the mean and one standard deviation above the mean, what did we have to do? We had to do some subtracting or some adding or whatever. I want this area, but when you look at your orange paper, will it give you a between? No. So I need to look both of these up in table A, and I need to write down what the area is for both of those. Go look both of them up and write down what that proportion is. Write down that decimal for each of these Z-scores. What is the area for negative 1.04? .1492. I drew a little sketch of what that means. You don't have to have a little sketch, but I want to make sure that we really understand what we're looking at and what we're finding. So the area from right here to the left, is that the area I'm interested in? So why did I find it? So I can subtract. That's the part on the other one that I want to take away so that I'm left with just the middle bit. What is the area for 0.96? 0.8315. That's this area. I want to take that little tail off the back, so I'm going to minus these two. Bigger one minus the smaller one. What do we get? 0.6823. If you did 0.682, would I take it? Yes. I like going out as far as the table will let us, especially because if I take that and change it into a percent, that leaves me with 2 decimal places after my whole number percent. That's why they take it out 4 places. But if you were to round it to 3, that's not wrong. We can also do this in your calculators. Either pull up the app on your phone or grab one of the calculators from the back. We're going to practice with this one real quick. We're going to check this answer to see if we can get the same thing. All right. So on the calculator, does anybody remember what we pushed so that we can start putting the numbers in? Second, and then vars, right here by the clear button, second and vars. And we want which option? Second option, I want normal CDF. You can either use the arrow key and then hit enter, or you can just push the 2. And if you're doing this on your phone, it should be the same steps. Now on the phone, it's not going to show you this. On the calculators in the back, it's going to show this. On the phone, you're going to have to type these numbers in and then put commas in between, but it should still be giving you prompts. Yep, it tells you what numbers to put in where. And there is a comma button on the calculator right here. All right, so lower boundary. Let's go back and look at our picture. What's the farthest to the left that we have things shaded? What's the lower boundary here? 193, if I'm looking at my original data. What's the upper boundary? 245. So 193 and 245. What do I put here? Mean. What was our mean? 220. And then what do I put here? Standard deviation, which was 26. Come down to where it says paste and hit enter. Should look like that on the screen. Now, when you use the calculator instead of table A to look things up, I need you to show me this. You need to write down where it says normal CDF and then parentheses and all those numbers. And you need to label those numbers so that I know what they mean. This one down here is my lower bound. LB is fine for lower bound. 245 is my upper bound, so UB. 220 was my mean. 26 is my standard deviation. You can write out the words and use SD for standard deviation if you want to. I use the symbols. Both of those are fine. And then you're going to hit enter. What do we get? 0.6823, which was exactly the same thing that we got here. Now the calculator is slightly more precise than we are. This right here is what we typed into our calculator. You can also type it in its standardized form. We could put in lower bound z-score, comma, upper bound z-score, comma, 0 and 1. You're going to get the same answer either way, or close enough that it doesn't matter. If it's not the exact same, it would be close enough. Before we move on to the next one, what questions do we have? All right. Let's look at number 3. Many artists are paid on streaming platforms according to how much time people listen to their songs, which encourages them to make longer songs. How long should an artist make a song if they want it to be in the top 10% of longest songs? So first thing I'm going to do, straight down the center, put my mean. Tell me it's a normal curve, put the mean and the standard deviation. Label those guys. %, of longest songs. Would longer songs have higher or lower times? Higher. So which side of the mean should I be on, left or right? Right. Okay, so I'm going to pick a spot somewhere on the right. Do we know the length? No, that's what we're looking for. So I'm going to call that X. Don't know what it is. And I'm going to shade. Let's see, I wanted 10% of longest songs, so I'm going to shade to the right. I'm going to draw a little arrow and explain what this is all about. Area is equal to, what's 10% as a decimal? 0.1 or 0.10. I'm going to write it as 0.10. 0.1 is fine. I get my 1% and 10% confused when I write them down, so that's why I'm writing it like this, so that I don't mess it up. All right. We want to try to find this value right here. So coming down to my standardized curve. What's the mean on a standardized curve? 0. It's a normal curve with a mean of 0 and a standard deviation of 1. Mean, standard deviation. So here's what I'm thinking. How do we calculate a z-score again? Value minus mean. So z equals my value, which I'm going to call x, minus my mean, divided by the standard deviation. Do I know this? Yes. Do I know this? Yes. Do I know this? No, that's what I'm looking for. If I can find a z-score and plug it in there, then I can work backwards, because then I'll have all but that one missing piece. That z-table in the middle, it gives areas, doesn't it? So look at table A with me. In the middle is area. To the left or the right? On the table, it gives us left, right? Area to the left of given z-scores. Did we shade ours to the left? We shaded ours to the right. We want to know at what z-score would we get to 10% of the area in this upper section. But I can't go look up 0.10 at the table because it's shaded the other way. So how do I make this so that I can use it? 0.90, yes, or 0.9. We're going to do 1 minus 0.10. So I get 0.90. This is my left tail. This one over here was my right tail. So we're going to be in the middle of the table. In here. This is where the areas are. We're going to work backwards to figure out what that z-score would have to be. So I want to find the score in the middle of the table that's the absolute closest to 0.90 that I can possibly find. When you think you have found the thing that is absolutely the closest to 0.90, tell me what that number is, because there's not exactly 0.90 in the middle. You guys are a little bit ahead of me. I want you to read the number from the middle of the table. Like, as I'm looking in the middle of the table, I see like 0.7939, 0.8962. What do we see? 0.8997. So that's right here. Once I have found the area that is the closest to 0.90, this is on the positive side, by the way, so it's on the back side of the page, I want to track it over to the left to see what the beginning part of my z-score is. So when I track this over to the left, I get 1.2. Do you see that? And then I have to go up to get the second decimal place. What's my second decimal place? 8. 0.8. So 1.2 plus 0.8 is 1.28. All right, so I have 1.28 equals, we don't know the x value, but we do know the mean. What is that? 220 divided by our standard deviation, which is 26. Solve that now for x. Does anybody have a number for me? I heard 253 and then I didn't hear the decimal part. 0.28. Should we put units with that? Seconds. So songs that are 253.28 seconds long or longer are in the top 10% of songs for their length. There's a way you can do this on the calculator also. I want to show you how to do it on the calculator so that you guys are well versed in both methods. So we're going to do second in vars again. This time we're going to go to option number 3. Do you see the one that says INV-NORM? The NORM stands for normal. What do you think the INV is for? Inverse. We're going backwards. We're doing the opposite of what we did before. We're doing the inverse here. Choose that option. We want option 3. I need to put the area in here. I don't want the area that they asked for. I want the area, like the percentile. So there and to the left. What was that area? 0.9. I want from there and to the left because we've got left highlighted right here. Leave it at left. And then I put in my mean, 220, and my standard deviation of 26. We're going to come down and paste. If you're doing the calculator app on the phone, it won't have the paste option, but it should still be prompting these pieces. I'm going to hit enter. This is what it looks like on the screen. Here's what I need to see on your page when you use the calculator. I do not need to see this. That part is just assumed. I need to see this, that 0.90, that was our area. The 220 was the mean. The 26 was the standard deviation. That's what I need to see on your paper when you use the calculator for this. You could get away with a percent sign. I would accept a percent sign there because it's giving us a proportion. And then we're going to hit enter. What was our answer before? 253.28 when we did it with table A. I got 253.32 using the calculator. They are 0.04 apart. Do you think that matters? No. Either answer would be considered fully correct. Why do you think the calculator answer is slightly different than when we did it with table A? Yeah, we couldn't find exactly 0.90 on the table. We had to get as close as we possibly could. The calculator has exactly 0.90 in there. All right, so we did inverse, norm, parentheses, 0.90, that was my area. 220, that was my mean. 26, that was my standard deviation. And we got 253.32 seconds doing it that way. Absolutely beautiful. All right. I would like you guys to find at least one other person to work with. Big ideas that we talked about between yesterday and today. Finding our proportion, we find our z-score, we look it up in table A, or we're going to use normal CDF in the calculator. You have to draw the picture. Drawing the picture shows me what you're finding when you do table A or you do the calculator. If I'm given a proportion, I'm given a percentage, then we have to find the z-score that has that proportion, work backwards, or you do inverse normal. If you find the z-score, you got to plug it in and work backwards to solve for x. All right? I would like you guys to take about, 5 minutes. Working with a partner, I want you to do part A and B on the check your understanding. Part A and B.
And I'm okay with that. Because she came over my house and we were trying to do the homework and I was like, Abby, I think you educated or not. She was like, no, I don't think that's it. She was like, if I'm wrong, I owe you $2. You owe me $2. Yeah. Those are the weaknesses. Yep.
Yeah, right.
Okay, so,
And then one's longer.
yeah, we just look at that.
Yes. What'd you get? Yeah.
You're trying to find a
This
really
is what we
possible.
want to stay for. But there's
Not bad. How are you going to find out? You found this. How are you going to close? You want this area. If you look for a column, you that. What's the area? Private. There you go. That's your Z-score. Edge to edge. What's the area? How would you describe this percent?
and that would be the rest of it, like medium. Or it's all given.
That one.
Yeah.
One.
All right. For part A, your original sketch should look like this. And then you should have found a z-score. What was the z-score? 0.32. So your standardized curve should look like that. We go over to table A and we look it up. Is that my final answer when I get over to table A? Why not? Table A shades to the left. We shaded which way? To the right. So you have to subtract it from 1. You do 1 minus whatever table A says. What do you get? 0.3745 or 37.45%. Part B. Your original sketch should look like this. What's the area we're interested in? 1%. Do I need to do the 1 minus and then look it up, or can I just use the 1% this time? I can just use the 1% because it is shaded which way? It's shaded to the left. So I can just grab that and go to my table and look up the z-score. You should get negative 2.33 when you look up the z-score. And then we work backwards. To find our x value, or you can do that one on the calculator. Oh, yeah, I know I did that right. Your standardized table should look something, or standardized graph, sorry, should look something like this.